This slide describes the overall framework of the approach, starting from video stabilization to pedestrian detection. The input video. This video is from the publicly available standard UCF dataset. It was obtained using RC-controlled blimp equipped with a camera mounted on a gimbal. The collection represents a diverse pool featured at different heights and aerial viewpoints. The flying altitude ranges from 400 to 450 feet. Stabilized video. Here, a video stabilization is applied to short sequences of 32 frames. We start with the first frame of each sequence and use it as the reference frame for the remaining frames in the sequence. Harris corner interest points are matched between the reference image and each subsequent image. We fit homography to the matching points using Ramsack. We then apply transform to align current image to reference image. The result, we have groups of 32 frames which are co-registered. Here, after stabilization, background subtraction is used to identify regions of interest. A background model for each group of 32 frames is constructed by computing the mean of the frames. Then the difference between the middle frame and the sequence and the background model is computed. Initial foreground regions are identified by thresholding the difference image. The foreground could correspond to real moving object or possibly static object due to non-perfect stabilization. Morphological operations are applied to eliminate small regions, and the connected components are found to obtain the final regions of interest. So those detected regions of interest appears here with the blue boxes. Detected regions, we slide window on them, searching for pedestrians. Detected pedestrians will be shown here with a height of 20 pixels. And the detection boxes will appear with the red color. Each box is of size 32 by 32 pixels, which is the same as our detection window. This size of the detection window is large enough so pedestrians remains within window throughout the sequence of normal winging speed. And here we see a false positive detected. Now in the second part, we will repeat the same experiment. We will show the results just in different aerial data set, which is kind of challenging data set from the standard publicly available aerial VRAD. And here we see the final results where pedestrian detected. Each pedestrian is of height 20 pixels, and the size of the windows is 32 by 32 pixels.